So we have just one page left in section 8.2. Let's see how long it can take us to do it. So we're still on the New Jersey Turnpike, and we have 750 drivers being covertly measured. What is the probability that less than 728 of them will be speeding? Okay, so it's the same kind of deal of what we found before, but a little bit different. So the issue is we're going to really need to find p hat. So before they told us p hat right up here. Hold on. They said 98.5%. That's a percentage. But down here, they didn't give us a percentage. Ah, but wait. We know that p hat is equal to, hold on, where is it? There it is, x over n, right there. Okay, so we're going to use that fact to find the sample proportion. So let's go down here. So p hat for, I'm going to put part C right here. It's going to be very similar. P hat this time, we'll actually have to calculate it, is equal to, oops, I'm going to move this over here. Okay, this is equal to 728 divided by 750. So it's 97%, which doesn't seem too small, but it will be. Okay, so now we're going to find this with both StatCrunch and with Excel. Okay, we'll be doing this the long way. All right, now for StatCrunch, we've got this part for part B. Let's go back to our StatCrunch calculator right here. It's right there. See it? All right, and we're going to say 0.98, 0.00511, just like before, but now I'm going to do 97067. I'm going to say less than for this probability and say compute, and then snapshot. This is 8.2, example 1C, I think. Export. Okay. I gotta figure out where I'm at. Ah, StatCrunch. Okay. So my results. There it is. And I'll just paste it in over here. It's not really off screen. I'm just zoomed in a lot, so if I zoom back out, I'm okay. But you can see it says that it was 0.0339, so 0.03394. I mean, if you want to type it all. 37808. Okay, so there's that. Now, how can we do it with Excel? Well, Excel is actually going to be pretty simple because, oh, I better label this. This was less than 0.97. Actually, you know what? I'll just say 728 divided by 750. There we go. I'll copy and paste that. Okay, so it's equal to norm dist or norm.dist, depending on your version of Excel. Now our x is this cell right up here. That's why it pays to calculate this in Excel. So you go, okay, there's that number, 0.97, blah, blah, blah. My mean is up here still, 0.98. Actually, it's right here, 0.98, comma. Now that standard deviation is 0.005112, blah, 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 comma, true. And there we go. And it's okay for norm dist because norm dist finds left probabilities, and that's exactly what this one was a left probability. So there we go. I've got that. I'm going to copy and paste the picture in because you could also see the answer in that calculator, I know, but I'm really doing it so I can get the pictures drawn because it pays for all these problems always to draw a picture for yourself. All right, now we agree, hopefully, that that's really low. Would that be unusual? Yes, yes it would. It's smaller than 5%. 5%'s been our threshold for unusual until forever, although we're going to be tweaking that quite a bit in chapters 9, 10, and so on. But up until now, it's been 5%, and it will still be 5% a lot of the time. Okay, so suppose your sample of cars was less than 728. Suppose when you went out on the turnpike, you really got that. What are some reasons that could be? Well, now, again, this is heading you up just a little bit for chapter 10. How do you know something's up, right? So suppose you went out on that turnpike and you really got 728, and then you figure out your chances of that is 0.0339. Now, what are the possibilities? It could be a fluke. It could just be random chance you just happened to find some low speed drivers that day. The chances of that by accident is 0.0339. It could be it's a biased sample. It could be maybe you weren't as covert as you thought you were, and they could spot your cop cars, or they had radar detectors, or it was a traffic jam that day, or I don't know, it was a day that a lot of slow people were driving. Who knows? So all of those would make it so that your sample was not truly random and unbiased. Okay, so that's a possibility. Or if these two are out, if you say no, 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 that's too low of a chance. I don't think it's just random accident. And you say, nope, I know people didn't spot us. I know this was a random, unbiased sample. If you take it for granted that these two things can't be, then that leaves you only one other option. And that's what we're dealing with in chapter 10. It means that maybe that 0.98 that came from that article, because it was some article that said it was 98%, maybe they were full of it. Maybe it's not 0.98, or maybe it was 0.98, but now it's not anymore. That's how we start going, nah, I think I'm proving that this is not the case anymore. Are you proving it 100%? No, but you're proving that it's very unlikely, right? And what your threshold is for very unlikely up until this point has been 5%. Again, we'll start playing with that in chapter 10 a bit. We'll make it 1% or 10% or other things. All right, we are all done in chapter 8. In case you didn't notice, there's not a lot of calculations in chapter 8. It's a lot of understanding, right? Understanding what could be messing with you, understanding the bead box and how it works, understanding how the sampling distributions are different from the regular distributions, understanding how to find the center, how to find the spreads of these things, how to prove that things are normal, i.e. is n times p times 1 minus p greater than 10 for proportions, or is it greater than 30 for means? Do you understand the difference between means and proportions, and can you spot them in a problem? All of those things you're going to need all over the place in chapters 9, 10, 11, and so on. All right. So chapter 8 is a very big theory chapter. It's not very big in what you're going to actually have to do the problems. But hopefully by watching these lectures, you've gained some understanding of how distributions change and how bigger proportions, bigger samples, all of that plays around with your numbers. All right. I'll see you back here for chapter 9. Oh, except don't forget to save your chapter 8 technology, right? Save it and upload it, right? So save it, upload it for grading, and I'll see you back here for chapter 9 and more Excel and more everything else.